I'm Luke, and with Jack, Joe, and Spencer, we took a look at the PicoScope waveform on a 2021 GMC Terrain so we could understand what the waveform actually means. We started by going onto AllData to see if we could get a description on how the injector functioned. We learned that this was a direct injection system. Unfortunately, AllData did not provide any real testing instructions with a PicoScope, so using our previous knowledge about fuel injectors, we probed into the ground wire and power wire, effectively testing across the connector. Once the wires were properly probed and the PicoScope adjusted correctly, we started up the Terrain and watched the PicoScope screen and the waveform that appeared on it. This was the waveform that was found on our PicoScope. Because AllData did not provide us with any information on how to actually interpret the graph, and the guide that Pico provided was inaccurate, we had to rely on Google for an answer on what the waveform actually meant. As it turns out, the waveform was actually quite simple and common among injectors. The large voltage spike seen at the beginning of the wave is when the injector is turned on. The small hump seen after is actually the voltage used to hold the injector on. The injectors effectively use the pull-in and hold-in winding function, and as we know, holding open a fuel injector is much easier than first opening one, which is why we see the large difference in voltage. The humps also indicate how long the injector is on for. The more humps that are seen, the longer the electromagnet is active and holding the injector open. The last part of the wave that you can see is the large negative spike. Interestingly enough, this is actually the injector reversing polarity to snap close the injector as fast as it can. All our testing was done with the attenuator on as to not damage the scope with the high voltage spikes. However, even if it was turned off, we would still get the same waveform, just with some higher voltage.